And I'm sure you're seeing in the chat, if you haven't done that also, go ahead and send your first and last name and the word hi. That just records your attendance that you are here today. And if you were here the past couple times, you already heard me say all this. I'm going to say it one more time in case anyone's new. The questions we're doing today are brain teasers, right? And so you should go in with the expectation that you may not solve all of them, right? And it's not a competition, so it doesn't matter if someone else solved 8 and you're only able to solve 5 of them or something, or whatever. And we encourage mistakes, right? So we want you to make mistakes, right? And that way you can learn from them. And the first week, we had someone who started to say something and then he backed down because he was, he didn't want to be wrong. And it turned out he was actually right. And then like last week, we saw me make a few mistakes, right? At one point we were factoring, I want to say it was 36. And I said something like 3 times 13, which is obviously wrong, right? But it's fine. Someone pointed out, we moved on. So don't be afraid of making mistakes. And, we're just here to have fun, right? So, and then someone else said in the chat privately that they don't have a camera on their monitor. That is perfectly fine. If you don't got a camera, don't worry about it. And if your mic's not working, you can type your answers. That also said, one quick note, if you're wanting to volunteer an answer, I'm going to ask that you don't just wave your hand because not all of you are on the same screen for me. And so there's a good chance that if you're waving that I'm not actually seeing you. So if you got something to say, you can either send it as a chat or you can just unmute yourself and go for it. All right. Does anybody have any questions before we start? Cool. And then just real quick, Brody, if you could send the chat with your name to everyone and not just me. I'm not the one taking attendance. That'd be great. Cool. Thank you. All right. So today we're starting with a completely new topic or idea or whatever. So if you weren't here for the past couple of weeks, it doesn't matter. And so what we're going to start off with looking at is the prime factorization of 75. And so basically what we're saying is that, let me grab a pen real quick. 75 is the same thing as 3 times 25, right? 3 times 25 is 75. And then we could split apart that 25 for 5 times the 5 is also 25, right? And that way we get these groups of 3 numbers here that we could say 3 times 5 times 5 is the 75, right? And so we broke the 75 down into its most basic numbers, the numbers that can't be reduced any farther, or in other words, prime numbers. And so the first part of the question is the prime factorization of 75. Yeah, okay. Is 3 times that 5 squared, right? Here we go. I knew there was a question on here somewhere. What are the factors of 75? So again, if you could just send them in the chat. And those messages are going to either be going to me, Dr. Kwon, or Maria. And again, these are being sent privately. That way everyone has a chance to figure it out on their own, right? Yeah, you're just answering what are the factors of 75. All right, cool. So I think just about everyone's put in an answer. Does anyone want to volunteer? You can just unmute yourself and go for it. I can go.
1, 5, and 25.
All right, so, whoops.
And 3.
And 3, all right. Let's throw a 3 in there. 5 and 25. Does anyone agree, disagree?
Well, I think there's 2 more.
Yeah. Like 75 and 15.
75. And we're throwing in a 15. Is that what I was hearing? All right, so we have this. Anyone got any more? Is this good? Sounds good. All right, cool. Yeah, and these are the factors of 75, right? Because what we're saying is that 1 times 75 is 75, right? 3 times 25 is 75. And 5 times 15 is 75. Right? All right, so, and the idea that we're trying to get to is that there's actually a little bit of a pattern with all of these, is that if you look at any of these numbers, the 1, 3, 5, 15, 25, and 75, they're all just a combination of our base numbers here, the 3, the 5, and the 5, right? And so if we look at it, the 3 is just the 3, right? And the 5 is just the 5. But the 15 is 1, 3, and 1, 5. The 25 is 2 5s. The 75 is a 3, a 5, and a 5. And the 1 we could say is 0 3s or 0 5s. Does that make sense?
Yes.
Okay, cool. All right, and this is kind of going over the same idea. So just to kind of reemphasize this. So what we're saying is that when we're trying to find these factors, we can choose 0 or 1 3s, because that's what we have available to us. So we have 1 3 here, but we could also choose 0 3s, right? And then we could choose 0 or 1 or 2 5s, because that's what we have available. We can not use them. We could use just one of them, or we could use both of them. And as a little notation here, we can write that as this. Like so, saying these are our choices. We can choose 0 3s or 1 3. We can choose 0 5s, 1 5s, or 2 5s. And so more generally, we can create this equation that 75 is equal to 3m times 5, or sorry, 3 raised to the m, I should say, times 5 to the n, where we see that m must be 0 or 1, and n is 0, 1, or 2. And so with this in mind, we can create a general type of statement saying that there are 6 possibilities, because we could choose 2 from the 3s and 3 from the 5s, and 2 times 3 is 6, right? Does that make sense?
Yeah.
If anyone has any questions, feel free to use your mic.
Yeah. I'm definitely cool with that. Like, if you just want to unmute yourself, ask a question, go for it. If you're a little shy or whatnot, and you don't want to speak up, that's fine. Send a chat. No one sees it except for us, right? It's a private chat. All right. So with that in mind, this one on your own, what is the prime factorization of 126? All right. Does anyone want to volunteer?
I can.
All right, go for it.
All right, so the first thing I solved was 126 was even, and I know it's not divisible by 4 because 26 would have to be divisible by 4. So I just divided this number by 2, so I would have 63, and that's just 9 and 7, and 9 is just 3 to the power of 2, 2, 3. And I got the prime factorization 2 to the first times 3 to the second times 7 to the power of 1.
7 power 1. All right. Or we could just write like that. Either way is fine, right? The idea is the same. All right. Anybody disagree? Got a different answer? Got a different answer when I say how they got a different answer?
I got the same answer, but I did it a different way.
How'd you do it?
So I divided 126 by 3, and I got 42 and 3.
And you divide by 3 and you got what?
42 and 3.
42? Right.
Yeah, I'm pretty sure that's right.
Yeah, that's good.
Yeah. And then I got 7 and 6 for the 42. And then 2 and 3 for the 6. And I got the same answer, just different way.
Yeah, exactly. And that's one of the great things about math is a lot of times there's many different routes that you could take to get the same thing, which is good. All right, so with this in mind, we have 2, 3 squared, 7. And we'll go ahead and rewrite that. And so how many divisors does 126 have?
Does everyone understand what a divisor is?
It's the numbers that the number can be divided by.
Yeah, like that.
And isn't it 7?
Yeah, 7 would be one of them. Because 126 divided by 7 would give us 18, right? I think so.
Let's go ahead and just think about it for a little bit and use the private chat, okay? Then I'll try to call in the next person.
Yeah, ready if you're ready.
All right. So let me go ahead and call on Brody. What'd you get and how? Can you explain a
Yeah.
little bit?
All right, so I got 12 because 2 can be 2 to the power of 1 or 2 to the power of 0. And then I multiplied that by 3 because 3 can be from 0 to 2, which is just 3. And then 7 can only be 0 and 1. So 2 times 3 times 2 is 12.
Mm-hmm. Yeah, I just added 1 to the power and then multiplied those numbers. Yep.
Did anyone get anything different or did it a different way?
I mean, I did a little bit differently. Wait, I just added 1 to each power and then multiplied the numbers.
Yeah. So you could definitely kind of jump straight to the answer like Colin did, where he just adds 1 to the powers. What I did, where I wrote down like this, that was just more of a visual aid, right? So everyone could see what's going on. But does this make sense to everyone? That 2 could be raised to the power of 1 or 0, and so that gives you 2 choices. And then 3 could be raised to the power of 0, 1, or 2. And so that gives you 3 choices. And you're multiplying all these number of choices together, and that gives you a total number of choices of 12 choices. Or really, we're solving for divisors, right? All right, cool. So how many perfect square divisors does 126 have?
Does anyone who hasn't went ahead and had a turn, does anyone want to answer who hasn't already spoken? Or maybe what does it mean to be a perfect square divisor? Does anyone know?
A perfect square divisor is a divisor that has 2 multiples that are the same integer that can be multiplied together.
Yeah.
Right. Another one would be 9, right? It has 3 times 3. Just an example.
All right. So basically, he's saying that it's a divisor in the form k squared, k some whole number, right? And as Maria just said, 9 would be a choice, which is 3 squared, right? And now we also got another one that's a little sneaky, right? And that would be 1, exactly, which is 1 squared. Now, if we go back to our thing where we had 2 times 3 squared times 7, we can just look at this and see what our choices are. Remember that we need 2 of the same number, right? And so we can look at this and we have 2 of the same number with the 3s, but we can immediately get rid of the 7 because there's not another 7. And we can get rid of the 2 because there's not another 2. And we can't make any other type of groupings, right? If this had been something like this, then we could say the 3 and the 7 and the 3 and the 7. So that's another grouping possibility, but we don't have a second 7. So we can't do anything like that. Does that make sense?
Yep.
All right, cool. So
Anyone had any questions before we move on? And this is a lot like mathematics, right? There's a lot of different patterns and tricks to get this maybe the same answer. So anyone have any questions or not?
No.
Yeah. All right, so we're gonna switch gears just a little bit, and I know right now you're looking at this and you're like, why on earth are we doing this? We're getting to a conclusion or an idea that we're heading towards. All right, what is 3 factorial? All right, cool. So far, it looks like everyone in the chat understands what factorial means. We'll get the formal definition in a second. And so everyone's right. 3 factorial is the same thing as 3 times 2 times 1, which is 6. And so more formally, we could say a factorial in, it's going to be n followed by an exclamation mark, right, is given by n times n minus 1 times n minus 2, going all the way down until we get to 2 times 1. And so just as a quick example, if we said, 6 factorial, this would be 6 times 5 times 4 times 3 times 2 times 1, going all the way down. Does that make sense? Does anybody have any confusion about that? All right, cool. All right. And so what is 2 squared times 2 to the third? And let's not, yeah, never mind. All right, cool. All right, and I know some of this is probably, fairly simple for you, but we're wanting to go through and make sure everyone knows this stuff before we go on to the, the more complicated stuff. All right, and so as a lot of people noted, this is the same thing as 2 to the 5th. And because we have 5, it's 2 plus the 3, right? And so that's our idea, that if our base numbers are the same and they are being multiplied against each other, then we are able to add those exponents under that same number, or over that same number, I guess. Right, and we're going to see a similar idea for this. We could say, what is 2 squared, all of that raised to the third? All right, cool. It looks like most people in the chat are getting that fine. And so we say that's the same thing as 2 to the 6, where 6 is 2 times that 3. Right, and so we say, in a general sense, we can write this down here, that a raised to some m and all of that raised to some n is the same thing as a raised to the m times that n. All right, now this is a little tricky. So definitely don't be surprised if you don't get it. I mean, if you do, that's awesome. But see if you could try to figure out a way to think of how many divisors does 1 factorial times 2 factorial times 3 factorial times 4 factorial times 5 factorial times 6 factorial. How many divisors does that have?
Do you mean different divisors or just divisors as a whole?
Divisors as a whole.
This one could definitely be a little tricky, so make sure if you think you have your answer, you're double checking.
Yeah, and there's no issue if you don't figure this one out, right? Right. Lots of different answers coming in.
Wait, if there's like a repeated factor, does it count as 2 factors or only 1 factor?
So let's say like you had 7 and 7, right? You would only count the 7 once, but do keep in mind that the 7 times the 7 for 49 is its own factor also. All right, so we've got answers range. We have answers of 21, 720, 15, 21 again, 5,040, 234, 720, 49, or sorry, 4,940, 144,
And
5,040.
I meant 5,040.
Okay.
Yeah.
Oh yeah, I see that you updated your number. All right, so does anyone want to volunteer what they did, what they think their process is?
I can.
Sure. What'd you do?
All right. So basically what I did was 6 factorial. It has factors of, oh, sorry, wait. Okay, so if you combine all of them, you're going to have 7, 1, so it's 1 to the power of 7. And then multiplied by 2 to the power of 6, and 3 to the power of 5, 4 to the power of 4, 5 to the power of 3. Or wait,
Wait, I got 1 to the power.
wait, sorry, no. It's 1 to the power of 6, 2 to the power of 5, 3 to the power of 4, 4 to the power of 3, 5 to the power of 2, and 6 to the power of 1. So 6 is going to have.
Brody, let me pause you just real quick. I'm going to let you keep going. I just want to make sure. Does everyone get the idea of why he's saying this? You know, if we look at each of these separately real quick, 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. 5 factorial is 5 times 4 times 3 times 2 times 1. I don't think I need to write all these out, if that's fine. And so we can look, we say we have 1 6, 2 5s, 3 4s. And if we keep going, 4 3s, right? And that's exactly what we have, 4 3s.
Do I continue?
Yeah. So if that's fine with everybody, Brody's going to keep going and say what he's going to say.
I'm still a little confused.
Okay, yeah.
Which part?
Why you like
Oops.
circled, like why the 3s got circled, why the 2s are getting circled, like why it, like.
Yeah. So we have this 6 factorial, 5 factorial, all the way down to 1 factorial, right? But the thing we have to keep in mind is that all of these are being multiplied against each other, right? This is what the original thing was saying. And so really, if we were to write this all out, 4 factorial, 5 factorial, 6 factorial, this would be equal to all of these numbers being multiplied against each other, right? And so we would write down the 1 times this 1 times this 1 times this 1 times this 1 times that 1. And we'll also have a 2 in here, right? And a 2 and a 2 and a 2 and another 2, right? This whole section of numbers are being multiplied against each other because we're multiplying each of these pieces against each other. Does that make sense?
Yeah.
Okay, cool. And then if we were to keep going, we would do the same for the 3s, right? We have 4 3s in here, and here. And so that's where this comes from is Brody, you then went through and just simply counted them up, right? We said that we have 6 1s, and so that's 1 to the 6th power. And then we have 5 2s, and so we could say 2 to the 5th power. And we keep going all the way until we get up to the 6, where we only have 1 6.
Does that make sense? If not, we're gonna take any questions.
Yeah, it makes sense.
Yeah. Anyone else have a similar question? It's okay to use your mic, ask your questions as you need, because even though it is your question, it might be also somebody else's.
Yeah, and this is tricky. All right. But if no one's got any questions, we'll let Brody keep going and see what he does.
All right. So, anyways, what I got confused on at first was, so 1 to the power of 6, I thought it had 7 factors, but really 1 to the power of 0 is 1, and then 1 to the power of 5 is 1, 1 to the power of 6 is 1. So it's really only has 1 factor. And then 2 has 6 factors. And then all the way to 5, 4, 3, and then 2. And that's just 6 factorial. Just in like a different order. And 6 factorial is 720.
Yeah, that's actually a really good point. That when we're looking at these, we could say the 1 times the 6 times the 5 times the 4 times the 3 times the 2. But as you just pointed out, this is exactly 6 factorial. What's really nice about that is, for the purpose of being lazy, right, you have a factorial button on your calculator, right? So you can just hit 6, hit that little exclamation point, and it'll pop you out 720.
I did it a different way.
All right, cool.
Instead of counting the amount of like different integers in each, so there was 6 ones. Instead of doing that, I just multiplied 6 times 5 times 4 times 3 times 2 times 1 and got 720.
Yeah. That definitely works out for this problem, right? Because we got to our answer being that 6 factorial for 720. I wonder if that would work out for more of them though, right? Like what if we only had this or something, 3 factorial times 4 times 5 times 6? Can you do the same type of pattern? I don't know. Yeah, it'd be interesting. Anyone else got anything? All right, cool. So we keep going. How many perfect square divisors does all of that have? And what we'll go ahead and do is let's rewrite that from the previous page. We had 1 to the 6, 2 to the 5, 3 to the 4, 4 to the 3, 5 to the 2, 6 to the 1. All right. All right, so we might have to go back. Maybe 720 is not the right answer. Let's hop back real quick before we keep going. Oh, right.
Wait, can I explain?
Yes, go for it.
So I actually simplified the 4 to the 3rd and 6 to the 1st. So after simplifying all of that, so 4 is 2 squared, right? So that would be 2 to the 6th. And then so if you simplify all the even things, you should get wait, let me check my work. 2 to the 12th, times 3 to the 5th times 5 to the 2nd. If you simplify all the
Yeah,
non,
I got the same thing.
yeah, and then if you add 1 to the exponent and then multiply all of them, so 13
4.
times, yeah, so 13 times 6 times 3, you should get 234, I think.
All right. Yeah. So if you got a different answer like that and you're pretty confident that you're right, definitely speak up, right? Because you might actually be. All right. And so
Wait,
if
what
if you didn't,
happened?
yeah. So if you didn't catch what he was saying, basically what happened is that we need to simplify down this 4 and this 3 because these aren't reduced all the way, right? This 4 is actually 2 times 2 to the third. And so with that in mind, we can write this as 2 to the third, 2 to the third. And we also have 2 to the 5th.
You mean 2 squared to the third, right?
Yeah. It comes out the same, right? I
Oh,
think.
sorry. Wait, yeah, you're right.
Yeah, because in this case we would add these, right? And so this would be 3 plus 3 for 6. And in this scenario, we would multiply the numbers for 2 to the 6. But either way works, right? So you're absolutely right. And so now we have 2 to the 5th times 2 to the 6th, which would give us 2 to the 11th. And so we can rewrite this now as 1, 6, 2 to the 11th, 3 to the 4th, 5 squared, 6. But then we can also break down the 6, right? The 6 is really just 3 times the 2. And so now we have an extra 3, an extra 2. And so we could say 1 to the 6, 2. Oh gosh, that's an ugly 2. Let's try that again. 2 to the 12th, 3 to the 5th, 5 squared. Does that make sense? And then we could do the same idea that we were talking about last time. That we have this 1 really only represents one choice because no matter how many times you multiply it against something, it's only going to give you a 1. So this is one choice. This is 13 choices. And remember that 13, the reason why that comes from is because we could choose 2 to the 0, which gives us a 1.
Wait, so what was the answer?
234.
We're getting there.
Yeah, I don't know yet, actually, honestly. And so we can multiply these all together. We have 1 choice times 13 choices times 6 choices times 3 choices. That's 13 times 9. And what is that? 90
Wait.
plus 27?
Isn't it 13 times 18?
Yes.
18. Oh, gosh.
It's okay. It happens, right? Just
Yeah,
as you guys make mistakes, we do too.
Yeah, and this is what I'm saying. My elementary school level math is like, whew. All right, so 13 times 18. Anyone got a calculator?
234.
234. All right.
I mean, you could have gone the 13 times 9 and then just multiplied by 2 at the end.
Mm-hmm.
Yeah, yeah.
What if it was 10 times 18 and then 3 times 8?
Yeah. Lots of choices. Something that's kind of interesting to think about, at least in my mind. Because you could also do something like 13 times 20 and then subtract 26. And yeah. But you rely on a calculator too long and those little tricks and they sleep out of your mind. It becomes harder to do. All right, so a proper answer, 234. All right, and I'm just going to copy this down real quick. All right, and so now we can go back to our question here. we're going to update this with our newfound base, which we could say is 1 to the power 6, 2 to the power 11, 3 to the power 4, 5 being squared. And that was it, right? 1,
Wait.
6, 2, 11. I feel like I missed something.
No, the 6.
Is there power?
Oh,
It was 1 to the 6, 2 to the 12, 3 to the 5th, and 5 to 5 squared.
Yeah.
yeah, sorry. I was looking at the that guy. All right, so here we are. And now we're saying how many perfect square divisors does this number have? And we know that it's equal to this, just in case you don't have it written down.
Definitely take your time to think about this one. Does anyone still need a minute?
I'm almost done.
Yeah, I'm almost.
Okay.
All right, someone in the chat said that they just got back. What was the question? And so just as a recap, if you're working on it, just keep working. But as a recap for since he just got back, we were able to show on the previous couple of pages that this number here, 1 factorial times 2 factorial going all the way up to times 6 factorial is the same thing as this here when we go through and we factor it all out. And so now the question is, using this, most likely you could do whatever way you want. How many perfect square divisors does this have? In other words, it needs divisors that are like numbers 4, 9, 16, that are, perfect squares. All right. Does anybody want to volunteer? And this is also kind of a complicated one, right? So if everyone can't do it, doesn't know what's going on, we'll look at some simpler problems first and then come back to this. But if someone's got it, feel free to.
Someone who hasn't spoken yet.
Ideally, yeah.
Tanvi, have you spoken today or no? And I hope I'm saying your names right, and feel free to correct me.
No.
Do you want to go ahead and try this one?
I got 12 because you do 2 12 times.
Sorry, what was that? You got 12 because.
It's like 2 to the 12th power.
All right. Do you want to explain your logic there, or your idea?
I wasn't really sure how to do it.
Yeah. Okay. That's fine. That's fine. Yeah. Like I said, this one's a complicated complicated looking thing. So it seems like there's a general sense that I don't think most people know how to do this one, and that's fine. Let's look at a smaller problem first and see if we can work our way up, right? And so what if we say, is 2 to the power 6 a perfect square? And ideally, don't put this in your calculator. So pretty well calculator. No.
Now keep in mind what a definition of a perfect square is, right? That's got to be one number multiplied by itself. So what would be k in this sense?
Actually, you know what? If go ahead and use your calculator if you want, because that way it might, spark some ideas.
I think they could do it without it. They're smart.
Well, yeah, I'm just saying, ideally do it without your calculator, but if you're really stuck, go ahead and use the calculator, see if it can give you some, spark something. I don't know what word I'm looking for. Spark the thoughts.
Some magic.
All right.
I have 2 answers so far that say yes, it's a perfect square. Does anyone know why?
Yeah, you got to answer why, guys. Like, it's a 50-50 chance. You could say yes or no. All right. Michael, do you want to say what you got, how you got it?
I said yes because you can divide 2 to the 6th into 2 to the 3rd times 2 to the 3rd.
Right, exactly. And that creates a perfect square, right? Because these are the exact same numbers. This is k and k. And so when we have something like this, where we have a number raised to a even exponent, it can be split perfectly in half. Just as another quick example, if we said 3 to the 1,000, this you're not going to do by hand, right? Or on a calculator, really, because this is such a huge number. It's crazy. But this could be split again perfectly. 3 to the 500 times 3 to the 500. And because remember that when we have these we have these being multiplied against each other, we add the exponents. Yeah, and as someone said in the chat, I kind of said the same thing as you, but I didn't give you credit for it. The exponent is even, so therefore it is a perfect square. All right, so with this in mind, let's look at something a little different. And let's say, I'm gonna grab a different color and keep this all separate. How many perfect square divisors does 2 to the power 6 have? All right. So the common answers I'm seeing are 1, 2, and 4. Does anyone want to volunteer? But I know I just pointed out those 3 different answers. That probably makes some of you nervous. Like, oh my gosh, what if I got the wrong one out of those 3?
I can.
All right, go for it, Aiden. What you got?
Okay, so 2 to the power 6 I just divided that by 2. So that means there's like 3 to the power of 2 to the power of 4 to the power of 6 plus 1 because of the 1. 1's a perfect square. So I got 4. I did a different one.
How'd you do it, Brody?
Okay, so since a perfect squares have an even exponent and 2 to the power of 6 is even, so it's a perfect square. You just calculate like all the even exponents. So like 2 to the power of 0, to the power of 2, to the power of 4, and to the power of 6, which is just 4.
Yeah, that works. And it's like we're saying, there's multiple different ways of doing things. Any of this works. And in case this wasn't clear, each of these are inside of 2 to the 6, right? Because 2 to the 6 is the same thing as 2 to the 2 times 2 to the 4. And so each of these are pieces. In other words, 2 to the 2 is a divisor and 2 to the 4 is a divisor. These are both also perfect squares because they can be split apart perfectly, right? This is 2 times 2, and this is 2 to the 2 and 2 to the 2. And just in case this one wasn't clear, that's just 1, right? Which is 1 squared. Right. Does that make sense? How we can see that each of the even exponents are a part of the bigger piece, the 2 to the 6, and each of those evens are perfect squares.
Yeah.
Okay.
Does
cool.
anyone not understand? So you guys are thinking you're ready for the big one? The question on the top?
I think I have an answer for it, but
Think so?
All right, cool. Let's give everyone else just a couple minutes to look at it, and then you can go for it and so what your answer is. So in the chat, someone asked what was the answer for that one. That one was 4. So now let's try to look at the big one and see if we can get an answer there now that we have a little more intuition, a little more, foundation. Yeah. Oh, and I'm getting some chats that are saying things like I got 10, but I'm not sure, and that's perfectly fine. Like, you're not confident with your answer, that's fine, right? This is stuff you haven't seen before. It's fine to not be sure if you're right or not.
And sometimes, even if you think your answer is right or wrong, we still want to hear your thought process. So please do share with us through chat.
Right. I think it was Colin, you were the one that said you thought you had an answer, right? Do you want to go ahead and share what you were thinking?
sure. Are you talking to me? Or?
Yeah.
Oh, okay. So they're asking for the perfect square divisors of what of 1 to the 6, 2 to the 12, 3 to the 5th, and 5 to the 2nd. So since we know that any even power is a perfect square, then we can include 1 squared. Wait, that's how to say this. Anything 1 to the power of anything is just 1. So we can only include 1 square, so that's 1 perfect square. And if we did like 1 to the 6 times 2 to the power of 12, it'd just be 2 to the power of 12. So we could take like 2 to the power of 12, 3 to the 5th, and 5 to the 2nd, and try to see how much we could rearrange it. So the perfect squares are like 2 squared, 2 to the 4th, 2 to the 6th, 2 to the 8th, 2 to the power of 10, 2 to the power of 12, or 2 to the power of 12. And we can take 3 to the power of
Wait,
2.
did you include 2 to the power of 0?
Well, that's just 1. So.
Yeah, but you still have to include. Wait, do you? I'm not sure.
And then there's 5
All
to
right,
the power.
that's a good question. So we've got, in case you didn't hear that, what we're talking about is, do we need to include 2 to the power of 0 here? Yes or no?
Wouldn't that just be the same thing as 1 squared? It would just be 0. I mean 1. So
Yeah.
I don't think it would.
I'm just gonna let's see. I'm gonna find how many perfect squares I can make by pairing them together. So for we could say 5 to the power of 0 and 5 to the power of 2, but it's just 1. So
We'll go ahead and write them down.
here.
All right, so we have this. These are all of our perfect squares that are readily obvious, right?
Yeah. So for the different perfect squares, I did. Let's see. Well, there's 6 of there's 6, and I did 2 squared times 3 squared and 5 squared, and then I did that with 2 squared with, okay, so 2 squared times 3 squared times 5 squared is one of them.
Yeah, and so what he's pointing out is that we could combine these different numbers together also, right? Because this is the exact same thing as 2 times 3 times 5 times 2 times 3 times 5. Those are 2 identical numbers, therefore it is a perfect square. Now, we don't want to go through and do all of those manually, right?
Yeah.
Right. So we ideally want to find a way to get the total number without sitting here doing 2 times 3, 2 times 3 times 5, 2 times 2, 2 times 3 times, and so on.
Yeah. So anyway, I just did. So there's 2 squared can go with 3 squared, 3 to the 4th, and 5 squared, and then there's it's 2 to the power of 0 to 2 to the power of 12, so that's just 7. And you can do that. We can mix that with 3, and you'll get different perfect squares. So that's 21.
All right. So make sure I was understanding you right. You said that we're having 7 choices for the 2s and 3 choices for the 3s.
Oh, right, and 2 choices for the.
Yeah, I'm just repeating what you're saying. So if I'm understanding you right, then fantastic. If not, correct me.
Okay, so you'll have 7 times 3 is 21. And then if you want to have 7 times 3 times 2 is 42. Then 7 times 2, which is 14. And 3 times 2 is 6. And you have to include one more because 1 squared is also another perfect square. Basically, you just add all these up, and I got plus the 1, so 84.
like so. Does anyone agree, disagree?
I got 42. I'm not really sure. I don't really get why they're doing like 7 times 3 and then like 7 times 2.
Yeah, I got
I just
42 as
did
well.
7 times 3 times 2.
All right,
Yeah.
cool. So we have a different opinion that all we need to do is just 7
Well,
times 3 times 2 to give us this 42.
well, let's see. If I do 2 squared times 1 times 1, I'll just get 2 squared again. So
Well, you have to calculate the
no,
perfect square divisor.
I just double counted because 2 squared times 3 to the power of 0 times 5 to the power of 0 is just 2 squared, right? So,
Yeah. It's exactly as like you said. What you were doing is you were double counting. 7 times 2 is a scenario, but the thing is that scenario is already included in this one, and so this 14 got counted twice. And same thing for this one. So you were on the right track. You just did a little extra at the end.
yeah. I wonder how much I would. So we're okay.
Hold on, you cut out there. I didn't hear you.
Okay, I'm just trying to see how much I double counted. So anything that goes with so yeah, I don't know.
Right. Anybody have any questions? Concerns? Maybe you think 42 is not the right answer? All right, cool.
No, I got 42.
All right, so that brings us to 8 o'clock. So that's going to be the end for today. Before you leave, please make sure to send a chat with your first and last name, and